Hi students. In yesterday's class, we discussed some problems by using moment area method by drawing a bending moment diagram for different types of beams, isn't it? So in this class, I will discuss some more problems using the same method, that is moment area method. Now coming to our first problem in this class is examples 21. So in the example 21, determine the slope and deflection at free end of a cantilever beam shown in figure. Take EI equal to 2 into 10 to the power of 4 kilonewtons meter square. So the flexural rigidity of the beam is given as 2 into 10 to the power of 4 kilonewton meter square. And we have to find the slope and deflections at the free end of the beam. That means at point B. So the diagram shown that the A is the fixed end, B is the free end, and C is the point up to which the UDL is acting from fixed end. So through the length of 3 meters, UDL is acting throughout the length of 3 meters. Total span of the beam is 5 meters. The UDL value is 10 kilonewton per meter. This is the small w value, 10 kilonewton per meter. This is the given problem, the given diagram. You have to first draw the bending moment diagram for this given beam. So what is the bending moment at different points B, C and A? First of all, find the bending moment values and draw the bending moment diagram as you are using by using your earlier knowledge in the chapter 2. We drawn the shear force and bending moment diagram for different types of beams in the chapter 2. By using that knowledge, you have to draw the bending moment diagram for this beam. So what is the bending moment at point B? So point B, the bending moment is 0 because there is no load acting on the right side of the point B. There is no beam at all on the right side of the point B. Therefore, the bending moment at point B is 0. And bending moment at point C. Bending moment at point C is also 0 because there is no load acting on the right side of the point C on the beam. Therefore, the bending moment is 0. If any force acting on the right side, the moment will be developed due to that load at that point. And bending moment at point A. What is the bending moment at point A? So moment, algebraic summation of all the moments on right side of the point A. So all the moments, what are the moments? The load acting between A and C. Due to this load intensity, the moment will be developed at point A. So what is the load? Total load? Load intensity is 10 kilonewton per meter. The total load is 10 into 3 kilonewtons. So 30 kilonewtons acting between A and C, which is concentrated at the center of the UDL. At the center means at point, from point A, it will be concentrated at 1.5 meters distance, isn't it? This total load, here the load intensity is 10 kilonewton per meter, every meter ki, but any meters act avutundi 3 meters act avutundi. So total load enta avutundi 10 into 3 kilonewtons avutundi. Idi ekkada concentrate avutundi? Center of gravity of UDL or rectangular load. That center of gravity which is at a distance of half of the total length of the UDL, that is 1.5 meters distance load. Okay, so 10 into 3 is the load acting, 30 kilonewtons. So movement at point A, therefore 30 into 1.5. 30 into 1.5 is 45. 45 kilonewton meter. Okay, like that you have to first find out the bending moment values at different points of the beam and then draw the bending moment diagram. So bending moment at point B, draw the first horizontal line which represents the baseline for the bending moment diagram. After drawing the baseline, locate the points A, C, B on that baseline and locate the values of bending moment values at point B, C and A. So bending moment at point B is 0, bending moment at point C is also 0, and bending moment at point A is 30 into 3, 45, 30 into 1.5, 45, which is developed clockwise movement. That's why minus 45 kilonewton meter negative. That's why I locate that 45 kilonewton meter below the baseline due to clockwise movement. It is negative bending moment. So locate 45 kilonewton meter on the line drawing from the A. Okay, and by joining these points we can get the bending moment diagram. So 0, 0, it is a straight line. There is no bending moment diagram. 0 bending moment diagram area here. And joining C and 0 and 45 kilonewtons by a parabolic curve. Why? Because the bending moment will changes across the beam between A and C parabolically. That is, it is UDL value. Whenever UDL acting, the bending moment diagram parabolic curve. It varies across the section with respect to x square. That's why I'm joining 0 and 45 with parabolic curve and close the curve to point A. This is the bending moment diagram. Okay, and locate the center of gravity CG of this bending moment diagram. How to locate the CG? CG formula is, location of CG is L into n plus 1 by n plus 2. Length between AC, the diagram between AC. So the diagram formed between AC only. So length is taken as 3 meters A only CG. So length into n plus 1 by n plus 2. N is 2 for the parabolic curve. So therefore n 2 plus 1 by 2 plus 2. 3 by 4. 3 by 4 into 3 meters CG location. 3 by 4 into 3 meters. Center of gravity, which is at a distance of 3 by 4 into 3 meters from C. Remaining distance is 2 meters. Okay. Like that, you have to locate the center of gravity for the diagram, bending moment diagram. So for this diagram, height is taken as 45 kilonewton meter and length is, total length is 5 meters, or length between A and C is 3 meters. So total area of the bending moment diagram between A and B is, this is the bending moment diagram area between B and C is 0, isn't it? The bending moment diagram area between A and C is LH by n plus 1. LH by n plus 1 is the formula for area of bending moment diagram for parabolic curve in case of parabolic curve. So L means total 3 meters. H is 45 kilonewton meters. So 45 into 3 divided by n plus 1, 2 plus 1, 2 for the parabolic curve. N is 2. So 45 into 3 by 3, therefore 45 kilonewton meter square is the area of the bending moment diagram. Total area of the bending moment diagram 45 kilonewton meter, because area of the bending moment diagram between B and C is 0. It is a line, simply line. And x bar means from C it is 3 by 4 into 3, 9 by 4. And x bar from B is 9 by 4 plus 2, 2 plus 9 by 4, that is 4 to the 8 is 17 by 4 meters, isn't it? X bar from B is 17 by 4, x bar from C is 9 by 4. Therefore, slope at free end, here in this case, we are going to find the slope at point B. If you want to find the slope at point B, the formula is theta B is equal to area of the bending moment diagram between A and B divided by EI, flexural rigidity. Area between A and B is 45 kilonewton meter square divided by EI value is 2 into 10 to the power of 4 kilonewton meter square. Therefore, we will get 2.25 into 10 to the power of minus 3, 2.25 into 10 to the power of minus 3 radians. It will come in radians. So if you convert the radians into degrees, multiply this answer by 180 and divide it by pi, then we can get the value in degrees. That degrees in degrees 0.128 degrees. Slope at point B 0.128 degrees. Also, if in the problem, what is the slope? He asked, if you ask the slope at point C, same formula will be applicable at point C also. So, what is the slope at point C? Theta C is equal to area of the bending moment diagram between A and C is equal to 45 itself. Therefore, slope at point C and slope at point B are equal. Because there is no load acting, the beam simply deflect but not bend between B and C. So this value is also slope at point C. Clear, students? Then deflection at point B, deflection at free end. How to find the deflection at point B? The formula for deflection at point B, YB is equal to AX bar by EI. AX bar by EI. Area means the A means area of the bending moment diagram between A and B. Here area 45, isn't it? X bar is 17 by 4. Already we calculate the X bar from B. X bar from B is 2 plus 9 by 4 is 17 by 4 meter, the center of gravity distance from end point. If you want to find the deflection at point C, you have to take the 9 by 4 meters only X bar. If you want to find the deflection at point B, you have to take the distance between CG to that point B. Okay. So 45 into 17 by 4 by EI value is 2 into 10 to the power of 4. Then we will get 9.56 into 10 to the power of minus 3 meters. It will get in meters deflection, displacement, vertical displacement. If you convert into millimeters, 9.56 mm, that is deflection of beam at free end is 9.56 mm. This is the extra calculator here. It is not asked in the problem. If you ask the deflection at point C, how to calculate. So deflection at point C, how to calculate the deflection at point C? Beam deflected like this up to point C, it is deflected curved line, and from C to B it is straight line. So deflection at point B is this much, deflection at point C is this much, and the slope at point B and slope at point C are equal if you draw the tangent to that curve which is coincide with the B and C points. This is theta B or theta C, both are equal. This is a straight line. Okay, the slope at this point is equal because it's slope line, it is straight line. So deflection, you asked the deflection at point C, how much deflected at this point. So how to calculate the deflection? Similar formula, YC is equal to AX bar by EI. Here the X bar is means distance of center of gravity from point C. This is 9 by 4. Okay. So AX bar by EI, A is the same value 45, area between A and C, into X bar is 9 by 4 divided by 2 into 10 to the power of 4 is the flexural rigidity. This is 5.06 into 10 to the power of minus 3 meters. Clear, students? If you convert this value into millimeters, we will get deflection at point C is 5.06 mm. Isn't it? The deflection at a free end is maximum and deflection at point C is less than the deflection at point B. Okay. Like this, you have to calculate the deflection or slope at any point by using moment area method. By drawing the bending moment diagram, we can calculate the slope and deflections. Clear, students? So let us see the another problem by using the same method. Example 22. Determine the slope and deflection at the free end again of a cantilever beam shown in figure. Again, the EI value is 2 into 10 to the power of 4 kilonewton meter square. So in this case, cantilever beam, this is the cantilever beam having span of 5 meters on which a UVL is acting. UVL means uniformly varying load is acting with intensity, maximum intensity 10 kilonewton per meter at fixed end and 0 at free end. This is the UVL value, uniformly varying load or triangular load. It is also called triangular load. So for this case, what is the slope and deflections at free end at the point B? Let us go for solution. First of all, draw the bending moment diagram for this cantilever beam. So bending moment diagram is, this is the diagram given, load diagram, 5 meters, 10 kilonewton per meter at fixed end, 0 at free end. What is the bending moment at point B? It is 0. Always the bending moment at free end of a cantilever beam is 0. And bending moment at point A. What is the bending moment at point A? Bending moment at point A is algebraic summation of all the moments on the right side of the point A. So what is the load acting on the right side of point A? Triangular load is there. So how to calculate the load value? It is the area which represents the area of triangle of into length 5 meters into height or breadth is 10 kilonewton per meter. Like this, you have to calculate the area of the triangle which represents the total load acting on the beam. Therefore, it is 25, isn't it? 2 5s are 5 5s are 25. 25 kilonewtons, which concentrated at the center of gravity of the triangle. Where the center of gravity is located, center of gravity is from the base or fixed end is h by 3 or length of the beam by 3, the 5 by 3 distance, 5 by 3 meter distance. So the load, which is 25 kilonewtons, which will be concentrated at the center of gravity of this triangular load. So that center of gravity is located at a distance of 5 by 3 meters from the base or 2h by 3 from the B point, free end. 2h by 3 means 2 into 5 by 3, 10 by 3 meter distance. Okay. So here we are going to calculate the bending moment at fixed end only. That's why I'm taking from the fixed end distance 5 by 3 meters. So 25 into 5 by 3, then we can get the moment at point A, bending moment at point A. So 25 into 5 by 3 is 41.67 kilonewton meter. Okay, 41.67, 25 into 5 by 3. That is also a clockwise movement will be developed up due to about point A. Clockwise movement is taken as negative. That's why I'm locating that 41.67 kilonewton meter below the baseline. Clear, students? Sorry. So after calculating the bending moment values, we can draw the bending moment diagram. Draw a vertical line from B and A, draw a baseline for the bending moment diagram and locate the bending moment values. 0 means on the baseline and minus 41.67 kilonewtons means below the baseline at point A. Join this 41.67 by 0 value to the 0 value. So how to join this bending moment diagram? If UVL is acting, this is cubic parabolic curve. Cubic parabolic curve. Okay? Cubically ga vary avutu untundi. UVL act అవుతున్నప్పుడు bending moment diagram. Okay, next let us take the area of the bending moment diagram. ఈ ఫామ్ అయిన ఏరియా ఆఫ్ ద బెండింగ్ ఫామ్ అయిన డయాగ్రామ్ యొక్క ఏరియా ఎంత అంటే LH by n plus 1. LH by n plus 1 means H is 5 meters, L is 41.67 divided by n plus 1 means for cubic parabolic curve n is 3. N plus 1 is 3 by 3 plus 1 4. So 5 into 41.67 by 4, that is 52.0875 kilonewton meter square. Kilonewton meter square. This is meter square. So this is the area of the bending moment diagram. Then how to locate the CG? What is the formula for CG? It is L into n plus 1 by n plus 2. It is the formula for to locate the center of gravity from the apex. L is here length of the beam, that is 5 meters. N is 3 for the cubic parabolic curve. So 3 plus 1 by 3 plus 2. 4 by 5 into 5. 4 by 5 into 5 is 4 only. So x bar is 4 meters. So from the apex at a distance of 4 meters, CG will be located. Clear, students? Are you understand this? How to calculate the area and x bar? After calculating the area and x bar, then we can easily find the slope and deflection at free end. Slope at free end. Slope at free end. If you want the slope at free end, this is the maximum slope. Simply theta b is equal to a by ei. That is the by Morse theorem 1. Morse theorem 1 ఏం చెప్తుంది మనకి? Change in slope between 2 points is equal to area of the bending moment diagram between those 2 points per unit flexural rigidity. So theta b minus theta a. What is the slope at a? 0. So theta b minus theta a is theta b itself. Theta b is equal to area between a and b. Area between a and b divided by ei. So area is 52.0875 divided by ei value 2 into 10 to the power of 4. It is given in the problem. Then we will get the 2.604 into 10 to the power of minus 3 radians, isn't it? Or you get it, my students? 2.604 into 10 to the power of minus 3 radians. It will be in radians. How to convert into degrees? It is by multiplying 180 degrees and divided by pi. Then we can get the degrees, slope in degrees. This is the theta b, 0.149 degrees, which is maximum slope at point B. Are you clear, students? Let us go for the next deflection at point B, deflection at free end. What is the formula deflection? It is comes from Morse theorem 2. What is Morse theorem 2? The change in deflection or net deflection between any 2 points is equal to the first moment of area between those 2 points per unit flexural rigidity. First moment of area means area into distance of CG from the apex. A into x bar by E into I. YB equal to x bar by E to I. So area is 52.0875 into x bar value 4 meters divided by 2 into 10 to the power of 4. Then we will get the answer as 0.0104 meters. If you convert it to millimeters, the deflection at free end is 10.4 mm. Clear, students? Up to now, we solved the problem by using moment area method for the cantilever beam for different types of simple loads. UVL, UDL, point load. Okay. Then next problem, I will explain about the simply supported beam, how to calculate the slope and deflections in a beam by using moment area method in case of SSB, simply supported beam. Let us see the example 23 in this chapter. Find the maximum slope and deflection in the given SSB, simply supported beam, shown in figure. This is the simply supported beam. It will not given in the problem. E diagram problem lo ivar, only the diagram which is shown above mentioned in the problem. You have to draw this bending moment diagram by using your knowledge. Okay. EI value is same 2 into 10 to the power of 4 kilonewton meter square. The simply supported beam means, what is the simply supported beam? The beam which is supporting on two supports at its ends. Clear? Ends దగ్గర support పైన rest అయి ఉంటే ఒక beam, ఒక horizontal member, that is called the simply supported beam, on which a point load is acting at center. 10 kilonewtons W is acting at point C. It is center point. So before going to draw the bending moment, you have to find the reaction forces in SSB. So it is acting on the center itself, 10 kilonewton meter. By symmetry, we can say that the load shared by the each supports are equal. Load shared by the each supports are equal. Therefore, reaction forces are equal. RA and RB must be equal to 10 kilonewtons and both are equal. Therefore, RA 5 kilonewtons and RB 5 kilonewtons. Okay. So RA, RB reaction forces at supports. After getting the reaction forces, then you can draw the bending moment diagram. Already we drawn in the second chapter the bending moment diagram for the simply supported beam for point load. So what is the bending moment at point B? Point B, the bending moment 0. Okay, one reaction force is acting at point B. Even it is passing through point B, there is no moment developed due to that load. That reaction force. Therefore, bending moment is 0 at point B. And what is the bending moment at point C? Bending moment at point C. This point దగ్గర bending moment calculate చేయాలంటే algebraic summation of all the movements, all the movements of forces. ఏమేం ఫోర్స్ ఉన్నాయి రైట్ సైడ్ లో? RB ఉంది ఒకటి అంతే. RB వల్ల ఇక్కడ ఎంత మూమెంట్ డెవలప్ అవుతుంది? RB వల్ల డెవలప్ అయ్యే మూమెంట్ ఎంత? 5 kilonewtons upward direction, which is acting at a distance of 2.5 meters off of the beam. So 5 into 2.5 is 12.5. 12.5 kilonewton meter, which is in which direction? Anti-clockwise direction. That's why positive. Positive movement will be developed by the reaction forces at point C. Therefore, 12.5 kilonewton meter is the positive movement. I located that point above the baseline. First, draw the baseline ACB and locate the 0 at point B and 12.5 kilonewtons at point C above the baseline. And point A దగ్గర కూడా bending moment 0 అవుతుంది. Bending moment at point A is also 0. I will explain how to hit 0. So ఇక్కడ మనం bending moment calculate చేస్తున్నప్పుడు movements algebraic summation of all the movements on the right side తీసుకుంటే ఈ 5 into 5 వేస్తాం, 25 అవుతుంది. Isn't it? 5 kilonewtons, which is acting at a distance of 5 meters. 5 into 5. Anti-clockwise positive, minus 10 kilonewtons is also there. 10 kilonewtons load, which is acting at a distance of 2.5 meters because it is acting at the center of the beam. It is clockwise movement kabatti negative. So 25 minus 10 into 25 is also 10 into 2.5 is also 25. 25 minus 25 0. So bending moment at point A is 0. Clear, students? Like that, you have to draw the bending moment diagram, which looks like a triangle. This is the BMD diagram, bending moment diagram. After bending moment diagram, after drawing the bending moment diagram, find the slope, maximum slope and deflection you asked. Maximum slope and deflection. Where the maximum slope and deflection occurs? Maximum slope occurs at the supports and maximum deflection occurs at the center. Clear, students? The beam bends like this. After deflection, beams looks like this. So maximum deflection at the center, maximum slope. If you draw the tangent at this point, maximum slope at point A, and also maximum slope at point B. It is negative slope, it is positive slope. So maximum slope at support, maximum deflection at center. These two are calculated by using moment area method. How to calculate by using moment area method? First of all, area of bending moment diagram between A and C. ఇక్కడ మనం స్లోప్ ఫైండ్ చేస్తున్నప్పుడు ఎక్కడైతే జీరో స్లోప్ ఉంటుందో ఆ జీరో స్లోప్ ఉన్న పాయింట్ తో కంపేర్ చేస్తూ స్లోప్ ఫైండ్ చేయాలి. ఎక్కడైతే బెండింగ్ మూమెంట్ డిఫ్లెక్షన్ 0 ఉంటుందో ఆ డిఫ్లెక్షన్ పాయింట్ 0 బేస్ చేసుకొని మిగతా చోట మనం డిఫ్లెక్షన్ ఫైండ్ చేయాలి. అర్థమైందా? ఫర్ ఎగ్జాంపుల్ ఇది ఇలా బెండ్ అయింది అనుకోండి, ఇలా బెండ్ అవుతే ఇక్కడ మనం టాంజెంట్ డ్రా చేస్తే ఇక్కడ స్లోప్ 0, isn't it? పాయింట్ సి దగ్గర స్లోప్ 0, ఇక్కడ స్లోప్ మాక్సిమం. సో ఇక్కడ స్లోప్ ఫైండ్ చేయాలనుకుంటే we must compare by Morse theorem the change in slope between 2 points, not 3 points, only 2 points. The change in slope between 2 points is equal to area of the bending moment diagram between those 2 points per unit flexural rigidity is called the slope. So ఇక్కడ స్లోప్ 0 కాబట్టి theta a minus theta c రాసుకుంటాం. theta a minus theta c is the change in slope between 2 points. Theta c value and the slope at point c 0. So therefore we will get theta a only, isn't it? And also deflection calculate చేస్తున్నప్పుడు ఇక్కడ deflection maximum, ఇక్కడ deflection ఎంత 0. So according to the Morse theorem 2, change in deflection between 2 points or net deflection between 2 points means yc minus ya. Deflection at point C, deflection at point A. Yc minus Ya is equal to first moment of this area. First moment of area between 2 points about apex. ఈ triangle apex ఏది A. So x bar ఇక్కడ నుండి తీసుకుంటాం. So area into x bar. This is the first moment of area about apex divided by EI. ఏరియా ఫస్ట్ మూమెంట్ ఆఫ్ ఏరియా బిట్వీన్ దోస్ 2 పాయింట్స్, ఆ 2 పాయింట్స్ మధ్యలో తీసుకుంటాం. అంటే మనం ఆఫ్ ఆఫ్ ద బెండింగ్ మూమెంట్ డయాగ్రామ్ నే కన్సిడర్ చేస్తున్నాం క్యాలిక్యులేట్ చేస్తున్నప్పుడు. క్లియర్? సో బై సిమెట్రీ వీ కెన్ సే దట్ ద స్లోప్ ఎట్ పాయింట్ ఏ ఈజ్ ఈక్వల్ టు స్లోప్ ఎట్ పాయింట్ బి, బట్ magnitude wise equal, direction wise are opposite. Clear students? Like this you have to calculate the CFO's slope and deflections. So that's why I'm taking the area between A and C off into 2.5 into 12.5. ఎందుకని ఇది ట్రయాంగిల్ షేప్ లో ఉంది కాబట్టి ఆఫ్ ఇంటూ లెంత్ ఇంటూ హైట్. ఆఫ్ ఇంటూ లెంత్ ఎంత 2.5, హైట్ ఎంత 12.5. 15.625 kilonewton meter square is the area. And x bar means the distance of center of gravity of the shaded area from the apex, from A. కానీ ఎంత డిస్టెన్స్ లో ఉంటుంది? మొత్తం 2.5 డిస్టెన్స్ బిట్వీన్ ఏ అండ్ సి. ఈ 2.5 మీటర్ డిస్టెన్స్ లో 2/3 మీటర్ డిస్టెన్స్ లో ఉంటుంది. ఓకే, 2/3 ఆఫ్ టోటల్ డిస్టెన్స్. 2/3 into 2.5. 2/3 into 2.5 is 1.667 meters. So 1.667 meter distance లో center of gravity of the shaded area ఉంటుంది. Then slope at point A is theta A equal to A by EI, area between A and C divided by EI. So 15.625 divided by 2 into 10 to the power of 4 is given in the problem, flexural rigidity. Then we will get in radians 7.8125 into 4 minus 4. If you convert into degrees, theta A equal to 0.044 degrees. Then deflection at point C, it is the maximum slope. Theta A is the maximum slope, and deflection at point C is maximum deflection. Maximum deflection YC is equal to AX bar by EI. These two formulas are very important. A by EI, AX bar by EI. Here A is the 15.625, X bar is 1.667 divided by 2 into 10 to the power of 4. We will get 1.302 into 10 to the power of minus 3 meters. It will comes in meter, it will comes in radians. Okay. Then if you convert the deflection in a millimeter, 1.302 mm. This is the maximum deflection upon acting of point load 10 kilonewtons at center of beam. These two are the maximum slope and deflection in the beam. Then simply supported beam with UDL. Simply supported beam with UDL. Okay, students. The simply supported beam with UDLs and the problem, and a simply supported beam with different types of loads And next problem is cantilever with multiple loads. So these two problems I will explain in the next class. I'm closing this class at this point. Have a nice day. Bye.